Hi, pre-calculus students. How you doing today? Welcome to section 1.4, functions, which you've looked at since probably pre-algebra. This is the way we like the world to work. For each input, there is an output and only one output. What does this mean in our math world? Essentially, when you have inputs and outputs, it means that X's are generally the input, Y are generally the outputs, and the X's don't repeat, right? So the reason why I say we like it, this is how the world will work. I'm looking for my Diet Coke. Hold on. Is that we like an input would be like a question. We like when we ask a question that there is an answer and that there's only one answer, right? So I always say it's kind of corny, but when you have a function, it's fun. When it's not a function, it's no fun. Function. Anyway, so what does this mean? Just really quick, we're going to go over some information here on what a function is. Even though you've seen it over and over, it's always good to go over it again. So what does this mean? When do you have a function? Here's examples of functions. Here's non-examples. Functions that are not functions, okay? And we have the representations here. The four mathematical representations: verbal, numeric, graphic, and symbolic. So what does it mean verbally when you have a function? It would be like when a student comes up to me, a pre-calculus student, and says, "Miss Culver, what's my grade?" And I say, "You have an 89%, right? For that one person's name, I have one grade." That person would not like it if I said, "Oh, you have either a 50 or an 89, right?" That would mean for this one person, perhaps her name is Anna. So if I put it in a point, it would say Anna, comma, 50, and then Anna, comma, 89, right? It makes the input or the X's repeat when there's two different outputs. We don't like that. Okay, what's a non-example? Would be like when I ask PowerSchool for a list of all the students with an A grade, right? And it gives me 10 students. That would be A is Anna, right? For A, there's Noah. For A, there's Corey, right? And so that, notice those X's are repeating and it's not a function, okay? So numeric, take a look here for each X that I have. Here's an example of a function. There is only one Y. For an input of 0, you can only output a 1. Input of -3, there's only a 4. 6, there's a 2. This is an example of not a function. Notice for an input of 3 that there's two different outputs, a -5 and a -2, right? Causing the X's to repeat, okay? What does that mean graphically? Here's a function. Graphically, if you remember VLT, the vertical line test, this is not something different than what we've already done. A vertical line is X equals something, right? We knew that. Here's the line X equals 1, X equals 2, X equals -1, X equals -2, right? So for each of these X's that we are just showing vertically, as a vertical line, we want there to only be one Y, to only hit at one point, and it does. So saying that the X's don't repeat in a function is this picture here. It's nothing different. It's not a trick, okay? Take a look here. This is not a function because for this, X equals, let's call that X equals 2 line. There's two different answers here. Maybe this is the 0.2, 2, and this is the 0.2, -2. Notice that because this X equals line hits the graph in two different places, it causes the X's to repeat. It is not a function. This is the hardest for students. Here, symbolic. Is how do you know when you've been given an equation whether it's a function or not? Well, there's a couple things you can do. You can turn it into forms that you already know, right? So Y equals X cubed plus 2. Is it a function? It is because it's under my function list, right? If you were to graph it, Y equals X cubed, hopefully you know what that looks like, the X cubed function, and it's been moved up 2. right? So it looks like this, right? And it's been, in fact, as long as we've already used this above here, here's a good idea. I'll just make the graph here above, right? There we go. Here's what x cubed plus 2 looks like. Notice that this passes a vertical line test. What else could I do? I could make a list of x's and put it into the function and output the y's and see if I can make an x repeat, right? Let's take a look. Let's say I put in a 1 for x. That would be 1 cubed plus 2. That would be 3. All right, well, let's put in a 1 again for x. When I put in a 1 again for x, can I get anything out other than a 3? No, I cannot. It's a function. For each x, there's a y and only one y, okay? So I could graph it. I could try the numeric method. I just want you to know also that if your y is to an even power, it's generally not a function. If it is to an odd power, it is. So there's a nice little trick for you there as far as symbolic, okay? Let's take a look. X squared plus y squared equals 25. We know what that looks like, right? From section 1.2, that's a circle located at a center of 0, 0, right? With a radius of 5. It looks like this, right? We did that already. Notice it does not pass a vertical line test. It is not a function. Notice also that the y has an even power. Another indication that it is not a function. Okay, hope that helps you on refreshing functions. Okay, let's move on. These are different kinds of problems that you will see in pre-calculus in your 1.4 assignment. All right, let's take a look. Let me tell you as we go along that you'll find that there's many opportunities for you to do factoring. So we may have to review that if you've had trouble with your factoring. Sorry, I have something in my eye. There we go. And, but you do need to factor on some of these problems. Okay, let's say you have been given, they want you to solve f of x equals g of x, and they give you f and they give you g. So let's set them equal to each other, right? Here we go. So we have x squared plus 2x minus 1 equals 7x minus 5. And they want us to solve this problem. Is the purple showing up? It is. Okay, so what I need to do, this looks quadratic to me because this x squared is not leaving. So I'm going to get everything to one side and set it equal to 0. I'm going to subtract a 7x and add a 5. Subtract a 7x and add a 5. I now have 0 on the right. Right? We're good at factoring quadratics and setting them equal to 0. And I now have x squared minus 5x plus 4. Okay, so I need two numbers that multiply to 4 and add to a negative 5. That would be x minus 1 times x minus 4. Right? These are two numbers that multiply to a positive 4 and add to a negative 5. Let's check it out to see if we have the same that's above. X times x is x squared. Minus 4x minus x is minus 5x plus 4. I sure do. But now I can set each one of these factors equal to 0. Take a look at x minus 1 here. What makes x minus 1 equal to 0? X equals 1. Here we go. What x makes x minus 4 equal to 0? 4, because 4 minus 4 is 0. And here are our two answers. X equals 1 and x equals 4 using factoring. Okay. They also ask you to use function values. So they give you a function f of x and they ask you, notice where there was an x, they have a 1. Right? So they are asking us to evaluate the function where x is 1. So we're going to do that. Let's put in a 1 where we see x's and we're just going to do some easy math, right? That would be 2 plus 3 is 5. There we go. We evaluated the function. Okay. Let's put in a 0. When we put in a 0 here and here, notice we get 0, but we cannot divide by 0. And so f of 0 is undefined. We cannot divide by 0. So you're going to find that right in algebra 2. It always came out pretty. It always came out nice. Now we're going to find things like this, that f of 0, we can't put it in for x, it's undefined. We're also going to find things like this. What is f of t squared? Okay, that might make you feel like, well, oh my gosh, I don't know what to do with that. Yes, you do. You do the same thing you already did. What did we do when there was a 1 and a 0? We put it in for x. So that's all we're going to do. All right, this might take a little bit more work, but let's take a look here. I'm going to put t squared in here for x and here for x. All right, so let's go ahead and do that. That would be 2. I'll use parentheses here. If it's okay with you to save room, since you already have these recorded, I'm going to erase. Okay, here we go. That way I can do the work above without squishing it in, and then you can't see it. Here we go. Right here. So here's my 2. Right here for the x, I'm going to put t squared cubed, right? Don't let it mess with you that it's a t cubed. We know what to do. 3 divided by, for this x right here, I'm going to put in a t squared and it's being squared. Okay, let's do a little math. When you have one exponent raised to another, you multiply. So I have 2 t to the 6th plus 3 t to the 4th. There we go. So what happens then? That's our final answer for f of t squared. What happens when you have a function and you input a variable into it? You get a new function. But don't think it's anything different. Just do what you were doing before. It'll work out. Okay, on 3b, what do you do if you have been given a piecewise function and then they ask you to evaluate the function? Okay, I want you to kind of picture this. Here's what's happening. So on a graph, if we took the time to graph it, there's this line 4 minus x. You know what that looks like. It is a line with a slope of -1 and a y-intercept of 4. You could draw it if I asked you to, right? Now, it only occurs on a graph for x less than 0, right? So if you had your xy plane only to the left of the y-axis where x is 0, you would see this line, right? So where x is greater than 0, on the right-hand side of the graph, it changes, the function changes to a parabola, right? So this is called a piecewise function because it's in pieces. All right, so what do we do when they ask us for f of -1? Do we put it into both functions? No, we don't. We said this function is in pieces. We said this line is happening if x is less than or equal to 0. This parabola is happening if x is greater than 0, right? So which one of these functions is going on where x is -1? The top one, right? When you put a -1 in for x, -1 is less than or equal to 0. This is the function that's happening when x is -1. So you only evaluate this function, the top one, at this x. So that would be 4 minus a -1 is 5. How about f of 0? Which one of these functions, only one is happening? That's what makes it a function, right? Right, a function is when you put in one x, you get a y out, not 2, right? So which one of these functions is happening where x is 0? This one is. It says right here, x. This function happens where x is less than or equal to 0. So I put a 0 into this function and I get a 4. Of course, next after 3, I want to make sure you know to jump to the parabola, right? What function is going on where x is 3? The bottom, the parabola, right? Because 3 is greater than 0. And so this would be 3 squared is 9. Okay. Number 4, what is the domain? They talk about domain and range, and that can kind of be a pain in the butt for students because you really just want to solve your problem. And now they're asking you for things like domain and range, but I'm hoping to make it easier for you. What is the domain? Those are x's that output a y. So an x is in the domain of a function if there is a y attached to it. Like you could actually plot an xy point. If you have an x that does not produce a y, that happened to us earlier, then that x is not in the domain. What is the range? It is y's with corresponding x value. So a y is in the range if there is an x value associated with it. If you have a graph or an equation and you have a y value that does not have a corresponding x value with it, it is not in the range and we have to remove it. Now, they will be asking you for domain in this section. And how do you know? Here's how you know. How do we find domain? Number 1, there's 3 steps. We assume everything's okay. Haven't we found mostly that when we have a function and we've been given an x that it outputs a y, doesn't that generally happen? So let's just assume like we would in life that everything's okay. Number 1, everything's okay. The domain is all real numbers. Every x is okay. Number 2, denominators cannot be 0. Okay, right, we found that earlier. Denominators can't be 0. So if we have an x that makes the denominator 0, we have to remove it from the domain. Number 3, when you have square roots in general, is what we'll see, or even roots, they have to be greater than or equal to 0, right? We cannot take the square root of a -4. We can, right? It's a 2i, right? But it's an imaginary number. But notice domain and range are real on the real plane. So even roots, especially mainly square roots, have to be greater than or equal to 0. So if you have an x that makes a square root negative, then you have to take that x out of the domain. So what are the domain of these functions? Let's run through, okay? F of x equals 1 minus 2x squared. Now the way I write domain, let's see if I can get you in here a little bit closer, right? Since we're on our last piece. There we go. That's better. There we go. Domain I usually just write with a capital D and a colon so I don't have to keep writing it. Number 1, everything's okay. Most x's are in the domain, okay? Number 1, all's okay. Number 2, denominators can't be 0. Let's take a look. I don't have a denominator, I'm good. Number 2. Number 3, square roots, even roots can't have to be greater than or equal to 0. I don't have any square roots. What does that mean? Everything's okay. My domain is x equals all real numbers. Let's take a look at B. G of x equals 3x over x plus 5. They're asking for the domain. Number 1, everything's okay. All real numbers. Number 2, denominators cannot be 0. Let's take a look. Oh, I have a denominator, right? X plus 5 cannot be 0, right? So x plus 5 cannot be 0. That actually is a statement of the domain, but we like it with just the x's. So let's subtract a 5. And this says x cannot be a -5. Let's circle that. X cannot be a -5, right? -5 plus 5 is a 0. I don't have a y attached. I don't have an output. Number 3, square roots, even roots have to be greater than or equal to 0. I don't have any. There is my domain. Okay, last. The square root of 2x minus 4. Number 1, domain, everything's okay, right? Number 2, denominators cannot be 0. I don't have any denominators. Number 3, even roots have to be greater than or equal to 0. This is a square root. Okay, what does this mean for me? This basically means that 2x minus 4 right here has to be positive, right? I can't take the square root of a negative number. 2x minus 4 has to be greater than or equal to 0, right? I can take the square root of 0. It's 0. That's okay, right? But I can't take the square root of a negative number. Now, this is a statement of the domain, but we like the x's alone, right? So I am going to add a 4 and divide by 2. Right, so add a 4, divide by 2. Here's my domain. X has to be greater than or equal to 2. Now, how do you write domain and range when you're looking at a graph? So we said for a domain, those are x's that have a y attached, meaning you can graph a point. Same with the range. How is a y in a range? Where on a graph, it's where there's a point graph for that y, meaning there's an x attached to it. Okay, so when you're looking at a graph and you're asked for domain and range, simply for the domain, look from left to right, that's where the x's are, right? And look for the x's that have points graphed. That's your domain. Okay, leave out anywhere on the graph where there's no graph for those x's. Do the same for the range. Range your y's, start at the bottom and go upward. And take a look. Do all y's have a point graphed? If they do, great, all y's are in the range. If not, you have to include in the range only the y's where there is a point graphed. So I hope this helps. I hope you have a great day.